when an attacker finds a vulnerability that allows them to execute commands, do remote code execution on a target system, oftentimes this is not too incredibly useful. Obviously, it's a big deal if they can execute arbitrary things remotely, but usually if they can only do one command at a time, sometimes it's not uncommon for them not even to be able to see the output of that particular command. They might have to use some other way to tell that the command is even being executed. One of the first goals, once they get to that point where they can, find a vulnerability where they can execute a single command, one of the first goals they have is to establish a full shell with the target system so that they can have a more interactive environment where they can send the commands and then they can see the results of those commands being executed. In general, we call these all just a shell, and it's highly advantageous because it greatly accelerates their ability to interact with the system. Even if the account that they're connected with is an unprivileged user, there are often other vulnerabilities. You'll often see these vulnerabilities chained together, where you're maybe the web user, the user that's created to be run to just serve web pages. They connect with that user's account, and then they have to escalate their privileges. And when they escalate their privileges, well, then they've got the whole system. So in any case, what I want to talk about today is different shells, the different shells that are available. When I say shells, these are just command line environments. These command line environments, this is often what we as administrators or security professionals will do our work. So it's not like we could disable these things. We really just have to restrict who has access to them. Typical shells that you will see that you'll use on a Linux system, there's your SH is the basic shell. You might see bash, that stands for born again shell. Again, it's just a shell. Another fairly popular one is called fish, which is friendly interactive shell. In any case, these are all different shells that are in Linux. In Windows, you have, you might have Powershell, or you might have, getting access to the command prompt, which technically whatever. So in any case, as far as getting connections, there's a couple of different ways you can do it. You can do a direct connection. Usually this would be, you might do something like a telnet connection. Now, telnet is, if you recall your networking, this is generally going to be over port 23. Telnet tends not to be used, or at least it's recommended not to be used for anything over the general internet because it is completely not encrypted. Even if it does require a login, the login credentials, your username and your password, get sent in the clear over the internet if you're connecting with Telnet. So in general, Telnet is not a good way to get a shell, although it does give you a shell. So most of the time, if you have any security involved, you'll see that Telnet will be disabled. Unfortunately, Telnet is enabled by default on a lot of like routers and things like that. So it's something to be aware of when you're in an environment. SSH is especially if you're talking about Linux, that is kind of the de facto standard way to get a remote shell. SSH goes over port 22, and you SSH into a machine, and you just get your shell. The nice thing about SSH is everything is encrypted. Your login credentials, and when you go to establish that SSH session, your computer, assuming it's connected to that particular IP address, will kind of do some fingerprint checking and make sure that the computer that you're connecting to now is the same as the computer that you've been connecting to previously. It checks it does some fingerprinting essentially. SSH, if it's over the general internet, I wouldn't recommend relying on just a username and password because those can be brute forced. Fortunately, SSH does enable you to use an RSA key instead of a password, or in addition to a password, either way. So you can get, basically, you can make an SSH connection as secure as you want. Remote PowerShell is another way. We're not going to, or at least I'm not going to spend much time on talking about remote PowerShell, but it's PowerShell remotely. It's kind of like these other ones. You can use you can do remote PowerShell over SSH. Yeah, in any case, being that I'm going to be doing this stuff in Linux, I will just be using SSH as my demonstrations today. Most of the time, firewalls will block incoming SSH requests. So if you have an internal network and you have SSH enabled to do any sort of administration on those machines, you have your firewall and you have the general internet out here. If somebody tries to initiate an SSH session from out here, it says, hey, I'm trying to connect to port 22 onto that computer in there. It'll go along, it'll hit that firewall. That says, the firewall will say, no, port 22 is not allowed to go this way. Or I don't know, maybe it's enabled, maybe it's disabled both directions, whatever. In any case, firewalls generally will block port 22, or at least that's a good habit to get into, blocking port 22. It's not always going to happen, but that's a good thing you should probably do. Now that does, of course, restrict, if you're, say, at home, it restricts your ability to do remote administration to these interior machines. And well, you might have to do a VPN or something like that to get over that firewall. Sorry, I didn't mean to bump the microphone there. So yeah, usually these direct shells, that tends not to be, at least, I don't know, that is one consideration. So being able to actually SSH in directly to the machine, that would be a very, I don't know, an easy way to exploit if you just had direct access. Quite frequently, because of these firewalls, you end up having, or the attacker rather, ends up having to make use of what's called a reverse shell. So how a reverse shell works is you have your interior network over here and you have your exterior network over here where your attacker is, with the firewall between them. Like I said, if you try to send an SSH connection from the outside, the firewall will block it. So what you do, since you can access, generally, you need some sort of access to the computers on the inside. So maybe it's a web server or something like that. Usually what the idea of a reverse shell is, you somehow make this machine that's inside the network, that's in the protected area, initiate a connection outward. And that connection that's going outward, once it's established, it will create a shell. Basically it's the shell creation goes from the machine that's giving the shell to the attacker. It's called a reverse shell because usually when you're trying to log in, you're saying, hey, I'm initiating the command, or I'm initiating the conversation. I want to see a shell on your machine. This reverse shell says, well, this computer over here is wanting to initiate the conversation, and it's the one providing the shell. So that's kind of the hallmark of a reverse shell. It's who's initiating that particular line of communication. So I will give a quick little demonstration. Okay, so the attacker is the computer on the left. Generally, how a reverse shell will start is usually how it'll start is the attacker will upload some sort of exploit or something that will trigger that, starting that connection going from the inside out generally requires something. You can't just normally tell that computer to create an outgoing connection without having that initial exploit. So usually you would start off by establishing that initial exploit. But let's say we already have that stuff set up. So what I'm going to do is, from the attacker's computer, I'm going to fire up netcat, and I'm going to use the options N, V, L, and P. So I'll let you look up those to see what those individual flags mean. So I will go ahead and you can see this is on the attacker's computer. It's currently listening on port 8000. It's waiting for an incoming connection here. So on the target system, I'm going to actually fire up netcat again, and I'm just going to use the flags N and V. I'm going to tell it to connect to the IP address 127.0.0.1. That's just a loopback address because I'm using the same computer, but if you're using multiple different computers, you just put a different IP address in there. This is on port 8000, and I want the -E to say, I want it to work with, to open up a bin bash. That's your bash shell, born again shell. So if I do that, so currently over here, that's not really, this isn't the system you're normally going to be interacting with. You're going to be on the attacking computer. So that's this one over here. And at this point, an established connection has been established. You can see if I do an ls here, I'm currently still running the netcat command. This ls is essentially it's being sent, that ls command is being sent over to the target machine. It's being executed, and then the output of that command is being sent back. So this is our reverse shell here. You can see it doesn't look terribly pretty. You don't have your typical your stuff showing up like you normally would, but it is a fully functional shell, and you can do things to stabilize this shell to make it so that it actually does look nice. Right now, like if I was to press the up arrow, it doesn't interpret that appropriately. It kind of doesn't know what was going on there. So you can see I executed up, I pressed enter, I pressed up rather than enter. And over here, there's actually an error that got spit out saying, hey, I don't know what that command was. One of the things you can do if you're trying to tell if there is a current connection, if you recall from some of the other stuff we saw, you can use netstat. And well, okay, just viewing netstat by itself, there's a bunch of stuff here. So we probably want to look just at netstat. I want to consider just TCP and UDP connections. And let's look at, well, yeah, I'll just do that. TCP and UDP. You can see there's actually two different connections. There is on the local side, port 8000, connected to, well, localhost port that. This is maybe a little bit weird because I am going from the computer to itself. You can see this is actually showing both sides of the connection. It's saying that I have this as my local address, and that's the foreign address, and then that's also the local address, and that one's the foreign address. So this is kind of, like I said, showing both sides of the same coin. This one right here is from the target system perspective. From the target system, this window on the right, it's using port 37772. That's just an ephemeral port that was picked at more or less random. And then the 8000, that is the target port. That's the foreign port, the foreign address, whatever. I'll forget foreign port specifically. So that's the port that was used for this particular window. But you can see that those connections are established using netstat if you wanted to do that. Let's see. If you're interested, if you're wondering what sorts of reverse shells there are out there, there's actually, Kali comes with a bunch kind of prepackaged. If we go to /user share web shells, you can see this is split into several different directories: ASP, ASPX, CFM, JSP, Laudon, Perl, and PHP. Usually how this would work, I'm going to the PHP directory, just to use that as an example. There are several different files in here. You can see the PHP Reverse Shell. This is the one that I would be, that I'm talking about right now, the reverse shell. And so let me look at this. In this reverse shell, how an attacker would go about the process, they would take, because a lot of attackers have access to Kali, or they might have their own attacking system. But in general, they would have some sort of reverse shells, most likely already downloaded. How this would work is they would take this reverse shell, this PHP reverse shell.php file. They would just change the IP address and the port number to be their attacking systems. IP address and port, because remember, this needs to make a connection from the target system back to the attacker. So when this PHP file is run, it needs to know where to look. So what they do is you would upload, or you would edit this file, or probably create a copy of this file and edit those 2 lines to be your attacker's IP address and port number. Then you would figure out some way to upload this file to the target system. So if you ever have an ability to upload files to a target system and they let you do PHP files, then it's really easy to get a reverse shell up on that system, because you literally, you edit this reverse shell.php document, you upload the PHP file, and to run the PHP file, how PHP works is it's run whenever you put that web address in. That's generally that's how PHP works. It's as soon as you access it, as soon as you try to load that page. So you go to something.php, it's actually executing a PHP file. This is the same thing. It works the same way with ASP or ASPX. So yeah, there's a bunch of different types of reverse shells here, depending on your system. If it's a Linux system, a web server, for instance, it's probably going to have PHP enabled. If it's a Windows web server, it's probably going to have ASP or ASPX. So yeah, that is a little bit of an introduction to shells and how they're used to get more access to the systems. All right.